quarantine. So thanks a lot. I appreciate it. Just to give you a little background, so I've worked at a number of large companies in media and publishing. I also was CDO, so Chief Data Officer, at a couple of different large companies here in the United States, multi-billion-dollar companies. And this was all before I started Dressler Consulting. So that said, let's go ahead to the next slide. Who has their drawing on, for example? Someone has to turn their drawing off. There we go. All right. So just to give you a quick agenda today, so I'm asked questions as a chief data officer. People are always asking, what can I do in data? I want to work in data. And so I thought, this would be a good opportunity to tell people, here's some of the stuff that you can do in data and where to get from data. I'm sorry, I'm just opening up a couple of windows here so I can watch. So what are we going to learn? What are some career opportunities, right? And we're going to explore that a little bit. We're going to look at what are the skills required for these opportunities, and then how do you get started? Really, how do you get how do you start that light the candle, so to speak? Next slide.
Before we jump to the next slide, let's see the results of our poll. Yes. So let's see where we are from, and so you can see the majority of the participants are from Kyiv. One is from Odessa. Cool. And we have a real data scientist here. I hope you will be happy to ask questions or maybe comments.
Excellent.
Thank you very much. Mm-hmm.
So I see a couple of comments here in the chat about changing careers. Interesting. We'll talk a little bit about that, or remind me to talk a little bit about that. Anyone changing careers is actually in an interesting position, and it can add some value to the companies you're moving to by layering different things on top of each other. Anyway, remind me to talk about that a little bit later. So one thing I realize this is English, maybe not your mother language. I am from New York, so I do speak a little bit fast sometimes. If I'm speaking too fast, just say slow down. Let me know. Happy to slow down, and I'll apologize in advance for going too fast on occasion. Anyway, if you need me to repeat anything, please feel free to ask that. And if it's not clear, also just feel free to let me know to clarify something. Next slide. So there's a quote that I like from Peter Sondergaard. He's from Gartner. He actually made this quote years ago, and he said, "Information is the oil of the 21st century. Analytics is the combustion engine." I don't agree entirely on the analytics part of the combustion engine, but I certainly do believe it is the oil of the 21st century. It is everywhere, and the people who are able to leverage that oil and figure out how to use the oil are actually the businesses that are going to succeed more than those that don't. Next slide. So when we talk about data and careers in data, what you'll hear is lots of different things. You hear big data, data privacy, data processing, databases, database administration, data security, data systems, all kinds of stuff. We want to kind of untangle this and make it clear to everybody. And to do this, we're going to use kind of a tool that I like to use. Next slide.
And we want to know which tools do you know that are useful for careers in data. Again, some poll.
All right, so that's a good question.
A very good one. So people are replying. That's very good. So let's see. 5, 4, 3, 2, 1. Let's finish the poll and see the results. And Chris, I would like to listen to your poll comments.
Ah, everybody thought Python. Interesting. Well, everybody's right. And the SQL, actually, that's an interesting answer there, because that's actually as right as anybody, right? So that's the other answers, all are good answers. In fact, there's no wrong answers here, so very nice. Let's look at the next slide here so these are just some of the tools that we talk about. Everybody's going to be using what is familiar to them or what they learn on. So you're going to have things from, where you're going to need to learn Python, you're going to use Excel, you're going to use different things. You may use Jupyter, which is an integrated desktop for data scientists, so to speak. You may be using Power BI, Tableau, etc. So all of these are good tools, and really what you prefer to put in your tool bag will help decide what you're ultimately going to be doing. So let's go to the next slide. I'd like to introduce a concept to you. So everybody knows Maslow, I hope, right? Maslow's hierarchy of needs. In this case, we're saying data science hierarchy of needs, or data hierarchy of needs. And this kind of a pyramid to help everybody remember where things fit and how things are. And we're actually going to build it from the base up so that we understand what we're doing in each of these different areas and layers, right? So on the left, you kind of have a technical, idea of what these layers are doing. Then you have on the right, you have kind of the roles of the individuals working in these various layers. So let's look at the next slide. So at the base of any pyramid is where you have the largest amount of work going on, a lot of physical work, like any pyramid, and that's the DBA, or database administrator, or software engineer. So these are the folks that are in the beginning. Next slide, at the bottom. So a software engineer, database administrator, these are the folks that are actually going to begin the process of putting together the databases, and they're going to work in both operational, and actually one of the few places where you're doing both operational and development work. You do have some specialization between developer DBAs and normal DBAs, but they're really focused on, what is the database that's being used, the updates that are being made. They're watching storage capacity, security, and they're constantly troubleshooting and validating performance on it. So we look at some of the hard skills that you're going to need. It's nice to have some, software development skills, particularly if you're a software engineer, you definitely need to have some. If you want to be a DBA pure, you don't need to lean so much on it, but you will need some. And again, I'd recommend Python here. You absolutely need SQL, so the SQL. You need, obviously, some operating system. You need to know a little bit about the OS that the system's working on. And then you're going to have some relational database management systems, so RDBMSs, that you need to know. So classic ones, Microsoft SQL Server, Oracle, Postgres, lots of, SQL databases out there. You may think of, some of these NoSQL databases in cloud computing. So you may have Hadoop, MapReduce, Pig, Mongo, Couchbase, etc. So those are important to learn some of those. The last one, you're going to be working with data schemas. If you're not familiar with data schemas, it's really, you're looking at all of the different parts of the data and the database. You're looking at keys, references, key references, things of that nature. So we like to talk about what personalities fit into these different roles. So the personality here is really, it's important to communicate, but it's not as important as some of the other roles, but you will need to have good written communication skills. You're going to need to be jumping from one problem to another. So this is kind of a nice thing to do if you're a DBA or an engineer. You're going to be moving from problem. You'll be working on at any given time 3 to 10 problems in parallel. So you're going to be jumping from place to place. If you don't like that, that's not a good place. If you like the excitement of moving around like that, you'll enjoy it. As in anything in data, you're going to need to be detail oriented. It's important, right? There's a difference between, the little differences can have a big impact. You do need to be patient. You need to be persistent, and you'll be working well with that. So again, some of the daily tasks that you might have, you're going to look at what the users are using. You're going to be setting up databases. You're going to be, you're going to use tools to organize your data, your records, and information that your company is storing. You're going to be updating databases, patching databases. Oracle, for example, releases a patch every quarter, and they actually have interim security patches in between there. You're going to be modifying data structures. You're going to be generating, profiles, user profiles, roles, things of that nature. And of course, security is always a big part of that. Next slide. So by the way, anybody, if you have any questions, feel free, interrupt and ask the questions. now's a good time whenever we're hitting it to do that. Or if you prefer, of course, we can wait till the end during the QA section. So the next part is we're going to look at data engineer. Next slide. So I like to actually kind of divide the data engineers into two groups. Now, not everybody agrees with me, but again, this is my opinion. But like anything, it's it is in the end, it's what you make out of it. So the data engineers, I kind of separate into two groups. One group being ETL development, the other group being data architecture. Some would say those are separate. They're not data engineers. I would consider that a category. At any rate, let's look at the ETL folks first, right? Let's go to the next slide. So for ETL developers, so ETL stands for extract, transform, load. In essence, what you're doing is you're moving data from system A to system B, and you're going to be modifying things in the process of doing that transfer. So that's the transfer, right? Or translate. So what you're going to do is you need to have some hard skills for doing that. SQL, you'll see, shows up all the time, right? You're going to need SQL. You're going to need something to wrap that SQL in, Java, Python, etc. You're going to need some other markup skills such as XML, which is a very nice structure to be using when you're moving data around. And you're going to need to know some database, data warehouse technologies if you're actually doing data warehousing. So some of these architectures and techniques, so you'll hear the word EDWs for Enterprise Data Warehouse. You'll hear something like ODS, which is Operational Data Store. You'll hear Data Mart, or DM for Data Mart. And those databases are, you're going to be looking at what you're actually going to be using, and you may use OLAP or you may use OLTP type transaction databases. And again, Oracle can be set up to do either. Same with Microsoft SQL Server. You just need to kind of figure out what is your need going to be. Are you going to be looking at a database and extracting someone's name and address, or are you going to be counting how many customers you have? So you're going to sort and count. Very different tasks for the databases. So again, the personality here is your enthusiastic personality. You've got interesting work every day, but you're going to be working to move data from system A to system B, or multiple systems. You need to have some project management skills, because you're part of a team that you're going to be that is going to be depending on you, and so you need to make sure that your deliverables are done on time. Like I said, you're part of a team, so you need strong teamwork skills. This is actually very analytical. You have to understand, what are you looking to achieve? How do you want to achieve it? And so there's lots of that. An example of this is if you're moving from a system that has your street address as think of it, your number and the name of the street being different fields or one field. So if system A needs it as one field, but system B has it as two fields, how do you do that? And so there's a lot of interesting problems like that. So daily work, ETL process management, writing, evaluating, testing, ETL scripting and programs. You're going to be managing your pipeline, your data pipeline, using different tools. So every day you're going to have any number of ETLs running. At some of the companies I've been at, we've had thousands of ETLs running every night. So there's a lot of work to be done there. Next slide. Oh, by the way, ETL, sorry, one last thing on ETLs. I think probably a good 40% of all work done today in data has to do with ETL work, just as a rough estimate. So there's a lot of work there, if anyone's interested. Next. So data architect. So here's kind of this is where you see a lot of people evolve from doing ETL work into data architecture. And data architecture is a very different problem entirely, right? You're trying to help define what are the structures that are going to be used by your application, your system, your database, and it's an important part of any project. So your data architect is going to absolutely needs to know some relational database management systems, so RDBMSs, right? Again, same thing, SQL Server, Oracle, etc. SQL, NoSQL systems like Hadoop, Couchbase, MongoDB, those are all important. Again, you're going to need to know some programming languages, and I recommend Python again. But if you know Java, Perl, etc., if you're good, you're good. You're going to be using that to test different ways of architecting data, and you're going to be using that to see the performance. You'll need to understand backup and archival software. So how do you back up these data repositories? Some of these things are very, very large systems. So how do you back that up, right, and prevent data loss? And of course, I think it's an underappreciated skill, but many people need to know what you're doing, and the best way to do that is by showing them pictures. And so Visio is a good drawing program. Any program really that can help you show in a picture what you're doing will go a long way. So they say a picture is worth 1,000 words, and that's absolutely true when it comes to data architecture. Personality, this is where you are working with other teams, you're working with other folks to understand how the data is being used. So excellent communication skills is a must. You will be both written and verbal communications, right? Analytical skills, you got to dive deep into the weeds, as they say here, is you need to understand everything so you can define what needs to be done. You are part of a team, so you need good project and resource management skills, and you're going to work very collaboratively with ETL developers, with application developers. You're kind of the middleman between all of these different areas. This is it's a relatively senior position, so it's not something you generally don't start out as a data architect. You work your way into that. Daily tasks, you're going to be designing, implementing database solutions. Those solutions will be taken over by others and used to do operations. You're going to examine and identify database structures and schemas. You're really going to need to know this, how they work. You're going to assess database implementations. I can't tell you how many times, as a chief architect or chief data officer, I've been asked to do an architectural review of data infrastructures, and that's almost a weekly occurrence at large companies. So you're going to install and organize information systems. Again, this is to do the research on how it's going to work. And you're going to prepare reports on this information as well. So this is a great role. And I think if anybody's interested in doing that, you'd be very happy to do that as well. Next slide. The next one up is we're looking at a data analyst, right? This is a very interesting role as well. It's kind of a middle person, so next slide. Excuse me while I take a drink of coffee. So the data analyst is actually kind of an interesting person. You're starting to move away from technology and more to data, so to speak. So a data analyst is generally not the hardcore, technical person that the earlier roles were. These earlier roles are very technical individuals. The data analyst starts looking at the data and focuses more on the data than on the technology. But even so, you do need to have some skills in technology. So again, the programming skills, the same as before, Python, etc. Right? You need to understand, SQL, XML. R, for example, is another language for data scientists. You're going to see, but you're going to use less of it, but you still need to be very familiar with it. You are going to be using more analytic platforms like and visualization, like Tableau, ClickView, etc. Because you're trying to understand, the data that you're working with. These are the folks who actually start to understand the meaning of the data and help people understand what it is. So when you look at a pile of data, you're going to see a number, X, Y, Z, and you don't know, is this number an address? Is it a time? Is it a birthday? Is it, different things that it could possibly be? The data analyst will need to know that. Interesting part about a data analyst, once you know that information and in a particular company's system, you actually become very valuable to them. And people who become data analysts tend to stay at companies for long periods of time because they're paid very well. Personality, again, this is very accurate person, very detail oriented. You're going to be looking at data and you're trying to figure out what is this specifically, And sometimes, the data is not documented well. So you have to actually play detective and figure out what is this. And you'll see a lot of that going on. This is, again, able to analyze and model and interpret data. Really a very logical person, very a thinker, so to speak. Next slide. Daily tasks. So things you're going to be doing is you're going to be using, computerized models to extract data that you need, right? So the first thing you're doing is you're pulling data. You're trying to understand what the data is. You're going to be looking at cleaning data up. So you're going to figure out how to remove corrupt or missing data. So how do you repair or not repair, decide to do something else? There's lots of things going on there. So you're probably the first person the business is going to start talking to look at the quality of data. You're going to be analyzing what data is, what's the meaning of the data. You're going to be the person who does the final, I would say the final analysis and screening of the data. You're going to be building lots of reports as well. So it's a very interesting position. It's really it's the starting point where you're transitioning from technologist that is not really interested or not knowing much about what the business is doing to actually being part of the business and the business owners. Next step, or next slide, please. So the next layer, BI analyst. This is an interesting role as well, and it's been around a while. Next slide. So the BI analyst is actually the classic person that you think about when you think of analytics within an organization. You've heard data mining and things of that nature, where you will be trying to figure out information that is important to the company and gives you a competitive advantage over other businesses within the industry. So very interesting spot as well. Hard skills, right? You need to know stuff like SAP Business. These are reporting tools, MicroStrategy, data pipeline, Microsoft Power BI. Any of these tools are really are fantastic tools, and you're going to need to learn one of those tools and understand it well. You're trying to ultimately understand and help the business make decisions based on how they're performing. So you're going to try and visualize that and show you're the CEO, which these BI folks generally work with, the senior executives in a company. And you're going to work with them, show them images, pictures, graphs that allow you to help them make decisions for the business. A good example of that is in the cable industry is, how many customers do you have in a specific area? You're going to be looking at how profitable you are as a company, how many employees you have, how many customers you have, what's the margin that you're making on each of the customers. Basic, a lot of stuff that is required by the government is also provided by them. So when you have a company that's publicly traded, you have to submit reports. Those reports are generally built by your business information or BI analyst. Next, your daily tasks, really. So actually, if you don't mind going back, we didn't talk about the personality. So this is the person who wants to understand the business and how the business is working and its objectives. You want to have a vision, and that vision should be aligned with the business. As always, attention to detail. You should be, this is where, it's good to know business stuff, right? And you see a lot of people who work on MBAs or organizational psychology. You see those folks going into becoming BI analysts. Again, very good communication skills, written and spoken. You are working with the executive C-suite. You need to have problem-solving skills and excellent time management skills as well. Next slide. So I kind of talked about what you'd be doing on a daily basis already, but just to repeat, this is where you're looking at customer data as it's collected. You're validating the data, providing reports on it. You're looking at the deployment of data warehouses, for example. That's primarily what they use, right? You're developing policies on what information can or can't be collected about individuals. You're looking for new data sources, so not just the stuff that you create, but other resources that you might be able to leverage. So reaching out to public data sets and incorporating our private, right? You're generally working together with corporate IT. Someone else is managing the data warehouse for you, one of the other roles. You're going to be monitoring, you're going to put up, monitor for analytics and metrics. And you're always looking at different methodologies. Next slide. So this is, now we're actually, as we get up, you're seeing we're getting more and more less technical, more business oriented. Now we're going to kind of reverse that trend a little bit. So a nice little joke, a data scientist is a business analyst that lives in California. As you would rightly suspect, many of these roles, as you work as a data analyst or in the BI analyst, you're going to use these skills, and over time you may get into and start wanting to do data science, which is a normal path. The next slide. So data scientists, right? These are the guys everyone's hearing about today. That's the sexy data job today. And everyone is looking to, or a lot of people are looking for it. By the way, it is a very sought after skill set, and they're for good reason. Good data scientists are very difficult to find. And it takes time to build up a resume and to build up the skill sets there. But you have to get started. I tell everyone, every data scientist had to start on one day and had 0 skills in the beginning. So hard skills, statistics, if you don't like statistics, you're going to have trouble with data science. You need to know at least one of these 2 programming languages, R or Python. I personally recommend Python, but R would work fine. It tends to be in many of the big implementations today, but Python is definitely pushing ahead of it now. You're going to be working with ETLs and developing some ETLs on your own. You're going to do a lot of what we call data wrangling, data exploration. So data wrangling is, and you'll often use the data analyst to help you, but data wrangling is collecting your data and dealing with all the issues you have with data before actually being able to process it. Dealing with missing data, dealing with bad data, dealing with, misrepresented data, and security and things of that nature. So you're going to be learning ML or machine learning algorithms. I would also highly recommend learning advanced machine learning algorithms, so deep learning, neural nets, things of that nature. You're going to be doing big data processing. So lots of folks think about data, and they like the term is the big data processing, which is all about dealing with high volumes of discrete data or little pieces of data. You have different frameworks you're going to be using. You're going to obviously need to visualize that data. You're going to be, if you haven't studied it already, you're going to be going back to math class, right? You're going to be learning that again. You need calculus, you need some linear algebra, and you don't need tons of it, but you do need some. And back again, you're going to see SQL, always, everyone's needing SQL. You're going to be using Java, Julia, Scala, MATLAB, different tools to process information, TensorFlow, for example. Personality-wise, so again, creative and critical. These are thinkers, and these thinkers are looking at how do you, what in the data is interesting and can help us predict future issues, and are actually will be used to help us predict future issues. And a good example of that is credit card risk or things of that nature. Very strong problem-solving skills. You are, again, dealing with the C-suite, so the executives of the company, so you need to be a very good communicator. Analytical thinking, always looking to the future. You're not worried about what's happening now, you're always worried about tomorrow. It's hard work, so it takes a lot of discipline and attention to detail. Next slide. So if you look at some of the daily tasks that a data scientist will be working on, it's kind of interesting, right? But by the way, it's all over the place. So these are the folks that solve business problems through, in this case, we say undirected research, but which all that means is, the company has a problem, they don't necessarily know where to search, so they're just going to search. They're going to start a very, wide search for everything. You're going to be dealing with open-ended questions, and often questions that you don't even know to ask, right? So you're going to be dealing with huge or large volumes of data. This data is going to be structured data, so SQL-oriented data, to unstructured data, images, things of that nature. I would say an unstructured data might be, you see a lot of research for when you leave a message with a company on their answering machine, you'll grab that answering machine data and want to go through that. You're going to use a lot of sophisticated methods for analyzing data. So you need to learn analytical methods and models. You're going to be doing machine learning. You're going to be using statistics and things of that nature to help you do predictive or prescriptive modeling. We do a lot of this work today, which is, it's very interesting. You're going to do exploratory data analysis. We call it EDA. You're going to look out how your data is being managed, and how do you look for trends in your data, so that you can either fix problems you will have in the future, or avoid those, or find opportunities to improve your systems as well. Some data scientists actually work on discovering new algorithms. You don't find a lot of folks doing that. That tends to move to the other area, the next area we're going to be talking about. But it is, it's about how you found an algorithm, and you're going to want to modify it and fix it to your, or utilize it for your specific problems. You're going to be communicating this information to the company, especially predictions, things of that nature, that helps the company overall. Next slide. And this is the very tip of the pyramid. And this is probably the hardest of all of the roles that are out there. And it truly is. It is what we're calling a research scientist, data scientist, core, machine learning engineer, are kind of the various titles you'll see or hear here. Next slide. We're not going to go into all of the detail, but if you think of a research scientist, what these guys are doing is they're actually developing the machine learning models that data scientists will be using, things of that nature. They are really very, you'll often find them to be PhDs out of the university. They know a programming language. They're very solidly. They do know probability, statistics, applied math. They're using all of their calculus skills that they learned in the university. They are looking at distributed computing. They're, they have a lot of strong skills. There's lots of tools in Unix or Linux, and so I would highly recommend those operating systems for that particular area. A lot of work in neural networks being done today, and natural language processing, or NLP. The example I gave you before is if people leave a unstructured message on an answering machine, hey, my system's not working, the systems are down. You'll use NLP to interpret that natural language, structure it, and put it into the environment so it can be dealt with. You have TensorFlow is very commonly used, Apache, Kafka. These are different areas that you need to understand as well. Personality here is where, this is a very creative individual there, because they're looking at problems that, don't really exist yet. And so you're looking like a data scientist down into the future to see if you can solve a problem before the problem actually happens. So that means understanding what could happen before. Again, problem solving skills, very effective communicator. They are working again with, the executive organization. There's a lot of analytics. And as I said earlier, always looking at the future. You need to be very patient here, because things don't move nearly as fast as you'd like them to. You have to have discipline and, again, attention to detail, same as the data scientist. Next slide. So again, daily tasks, you're going to be doing research. You're going to be looking at designing and building new machine learning machine learning systems. You're going to understand and transform prototypes for data, and you're going to be doing lots of that. You're going to verify data quality. Hopefully you've had the data analysts to help you, fix data. So now you're looking at data, and you're actually then validating it and testing it and using it. You'll be performing machine learning with models, right? Testing and experiments. You're going to get a set of data, and you're not going to know what to look for in the data. So you'll run it through and see if you can find any patterns in it. which is effectively what you're looking for. There is a few other things that we're doing here as well. You're looking for ultimately what is the right machine learning algorithm for a particular problem that you're learning or trying to deal with. What I mean by that is if you have your problem is you're trying to figure out where to put a McDonald's, right? So that is a very different problem than finding the fastest way through a city, you know, if you're doing, if you're driving. So there are different categories of algorithms and different algorithms within those categories that you're going to be using. So you're looking and doing a lot of that. Next slide.
Yes.
So I hope that helps everybody understand. Vida?
Yes. And as I already told you, we are going to collect the data. The webinar is about data. And I would like to ask you, do you think that in every company there are all these positions? DBA, data engineer, data analyst, data scientist, business intelligence and ML engineer. Then waiting for your replies. So 3, 2, 1. Chris, can you comment on this? Do you agree with the results?
That's excellent. Actually, everybody is correct. So
we have a good audience.
But to be fair, both answers were correct. So, so as with anything, it depends, right? So we'll after we have a chance to everyone to read this cartoon a little bit. It very much depends. Every company, you know, there's not a one size fits everyone type of a problem. So next slide. So what I'd like to do is just for people to think about it, and if you have any, again, comments or questions, everyone, this is a pyramid that is, you'll see it used here and there within the industry. And it's not a right or wrong, it just gives a little bit of a guidance. There are a few things to know about it. The pyramid A is there are far more roles and job opportunities at the bottom of the pyramid than there are at the top of the pyramid. So, you know, you think of, you'll probably need 5 DBAs for every AI deep learning person that an organization would hire or more, right? So this is why you want to, if you're thinking of a career, and it depends on what you're looking for. If you're looking for job security, you know, it's a very different problem than if you're looking to be learning and jumping from job to job. At any rate, every person sees this pyramid a little bit differently. And I'm again showing you what my opinions are. But let's start with the small startup company, a startup or a small company. What that means is your company may be overall, let's say 50 people, but your data organization is really 1 to 10 people. And if that's the case, you're not going to need or have any AI or deep learning researchers at the top of the pyramid. But it is likely that you'll have something in the bottom 5 quadrants. And if you're a data scientist, for example, you're going to be doing everything from the very bottom of that pyramid to the very top. You do not have specialization in these roles at this point in time. You may actually have a little bit, but you're not going to have a lot. Ultimately, if you have 2 people, you're going to want to distribute the tasks, and at that point, you're going to start to specialize. But there's a lot of overlap, as you can see. Let's go to the medium, next size company. So is a medium-sized company. This medium-sized company is where you're going to start to see some overlap. You have, it's probably a company of 100 to 200 people, maybe 500 people. You're actually going to see 2 different kind of specializations. You're going to see a specialization of operational technologists and then development technologists within an organization. Of that, you're going to probably see 10 to 25 people on the data team. Some will be focused on the operations every day, making sure everything's working. Some will be focused on, you know, building new platforms and updating and releasing new software. In any case, the first places you do see real separation and specialization is at the bottom layers, and that is because they are more common and more frequently, and you do have more of those individuals being hired. So you will see some, you know, specialization with DBAs. You'll see software engineers. You'll even see some database developers. The other place you'll see that is as a data engineer. You're going to see those folks starting to separate as well. Where you're still getting a lot of overlap is in the next 3 areas. So you're going to be where you're looking at the explore, transform, aggregate, and optimize layers. Right. This is where you're still going to see data scientists, data analysts, BI analysts. Every company has a particular title that they may like, but they're effectively performing the same activities and duties. So the data scientist, let's say this company calls it a data scientist, and will be doing everything that a data analyst does and BI analyst does as well. They may call it a BI analyst, but he's actually doing data science. And I've seen all of that. You'll also start to see a little bit of specialization at the very top as well. You may find what I would say is a very senior data scientist, or you may actually see a research scientist that's been hired, and they'll perform that for those very top 2 layers as well. Next slide. And now you get to large companies. You've got a lot of people. This could be anywhere from a $500 million company to a $40 billion company. All of them are the same. At this point, they've specialized, and in fact, I was talking to a bank just the other day with over 150 data-related individuals on their data team. But they've now specialized into very specific areas, right? You've got everybody in their own layer, and what they start to do is they'll build project teams across those layers. So what they'll do is they'll pick a DBA, a data engineer, a data analyst, a BI analyst, a data scientist, and a research engineer. They'll form a team, and that team will then approach or look for an approach and attack a particular problem or solve a problem. And so you'll see them organized in many teams, and so the company is basically dealing with or trying to resolve anywhere from 1 to 10 different problems, and they have these teams assigned to it, or more. Next slide. So does anybody have any questions, any issues, any questions from that that last slide? All right, or the hierarchy. All right, next, Vida.
Yes, and again, collecting the data. So before we comment on this, I would like to hear your comments on this. So please, what do you think? What are the most important skills? How to start the career in data? What do you need to do? I can tell you a small insight that we have everything needed in our course. So you can start here. Tick, tick. And then 3, 2, 1. Let's end the poll and see the results. Chris, do you agree with the results?
Interesting, very interesting, actually. Yes, I do agree. It's always good to ask your friends and stuff like that. Learning math and statistics is never bad. It's interesting. I just told someone the other day, I took an online astrophysics course simply to keep my my physics and math skills functioning properly, because I do need to deal with statistical and analytical problems. So yeah, I agree. Actually, I think everybody here has, again, there's no wrong answer here. Mm-hmm. I think all of these are dead on.
Good.
All right, next slide. All right, so my advice, right? My 2 cents for what it's worth, right? If you're not sure about getting a job in data or whether you want to do it, I actually think you could dip your toe in the pond, so to speak. So this is where you want to learn SQL, right? I think one of the common threads across all of those areas is SQL. In every single role, you will need to know sequential query language, right? So this is an important thing. It's been around for a long time and is the primary method for doing and extracting data from databases. Even NoSQL databases have SQL-like interfaces. So though it's not SQL, they do follow the same structures as those. So I also recommend picking a language, right? In this case, You know, I think Python, this is the way to go right now. It may change in the future, but I think that would be a good start to getting, getting going. The nice thing about that is if you learn SQL and Python, you actually, if you decide I don't want a career in data, you actually could become, start a career in software development, because you'll need to know those very same skills to be a software developer as well. I also think it's good to learn a database. You should use or learn to use a particular database such as Microsoft SQL Server or Postgres. It doesn't really matter which one, but every database has its own idiosyncrasies, its own little special things that it does. And it's important to learn those as well. The last thing is always, it's always important to show the work and the importance of what you're doing, and that is through the visualization of that data. And to do that, you need a tool to do that, a visualization tool. And a very good one that I recommend today is Tableau. The reason I say that is they have basically a free version for beginners, and you have really a complete, access to what it can do, and it'll teach you, how to do graphs, plots, how to represent data in a visually appealing way. So these skills, if you have these skills and you decide not to be in data, you can use those in many other areas of technology. Next. So now the next part is to decide what you want to do. So if you've decided you want to be a DBA, right, then you take a DBA course. There are courses for a particular database. So if you want to be a DBA for Oracle, then you take an Oracle Database Administrator course. Walking into that Oracle database DBA course, right, with those Python skills that you've learned earlier, or those SQL skills that you learned earlier, will accelerate your ability to perform well and graduate from that DBA role. Same goes for data engineer, data analyst, etc. Find a place where you can take that course in that specific area, subject, or find something, for example, if you want to evolve into a data engineer, become a DBA and learn software development skills, and you can then evolve into ETLs and then evolve into a data architect. So for those areas, it's a great place to start. For a data scientist, there's, we offer a boot camp, and that's a great place to start. It's a 3-month education. For a research engineer, yeah, I think that's a university. You really need to start at the university. That is a very, I think that's a very senior role. You need a good education and a good, strong math background to do that. Next slide. So after you've done this, right, as you're taking this course, you want to build out a great resume. Most places where you take courses will teach you or help you build your CV. CV is or resume, right? And they allow you and help you make sure your abilities, your personality, you shine above the others as well. So that's important. You're also going to need to build a portfolio. So in any company today, they're going to want to look at the work you've done in the past. And the best way to do that is to build your portfolio. I recommend GitHub, there's Kaggle and others, but you will inevitably be asked to show examples of the work you've done in the past. So if you're not collecting that, start collecting that information. Also, you want to start applying for internships, and as those internships show you or give you exposure to the real world. I highly recommend you also take and attend any interview you're offered. The more interviews you do, the better you'll get at them. And the better you do at interviews, the more opportunities you'll be offered. The more opportunities you're offered is the more money that you can earn if that's what you're looking for. So in addition to that, and the last thing I really think you need to do is think about the area that you want to specialize in. So banks are, as an example here, but you have every industry you can imagine: advertising, pharmacy, farming, agriculture, flight, logistics, shipping. Every industry has its own niches. But what happens is, as you learn, if you're focusing on banks, you're going to do a lot of risk analysis and portfolio analysis. So they're very focused on how do you understand and quantify risk associated with activity within the bank, right? Credit cards that are being offered, loans that are being made, stocks and bonds that are being purchased and sold. across the world, right? So and this information is unique to that industry. Same goes for advertising, marketing, etc. Those are all very, very important. The other thing you might think about is, I think about tools that the data industry uses. So, this tool that I talk about, Tableau, for example, or or Oracle, those tools are built by a company, and those companies need people who are understanding those areas as well. So look at the companies that build data tools if you want to get into data. They inevitably will be using those skills more than most companies will. And I know they're always looking for good help as well. Next slide. A few other last tips and tricks, right, to think about. Everyone, I always mention everyone's looking for DBAs. If you're, like I said in the beginning, there are lots of opportunities for DBAs, but you need to choose a database. The more databases you know, the better it is. So if you're certified in Oracle and Microsoft SQL Server and Snowflake, then you will have more opportunities available to you than if you're just certified in Oracle. Either way, this is where you want to get a certification for a particular database. And the better and more advanced your certification is, the more money and the more opportunities will be made available to you. But there are lots of database administrative jobs out there, and they will always be coming. Most companies, I should say, do not really have data scientists, right? But they are highly in demand. And the reason most companies, I think, don't have them is because they're relatively expensive. And so small companies can't really afford them, and they don't really actually know how to use them. That said, if they are a very data-driven company, they will have lots of data scientists, right? And there are lots of companies that are data-driven, and therefore there's a huge demand for data scientists. In fact, the most sought-after job last year and potentially this year was actually data scientists. Or the most open job requests were for data scientists. So the other thing is you want to look at companies with more than 50 people. The more after that, initially you're going to see a lot of rudimentary work being done, but after 50, for a number of reasons, they really need to start looking at data. And this is where you're going to start seeing more and more utilization of data scientists and data specialists for companies that are larger than 50 people.
Yes, the most interesting questions. How much do they earn? So again, I would like to see your comments on this. And while we are waiting, can I please have a next slide? So we've done some research on data scientist salary estimates in New York. And let's see what we have. So we have the results from different job search websites. For example, Glassdoor says that it's around, the salary is about 88,000 up to 1500,000. And then Built in New York City says that it's 55,000 up to 2,500,000. It's per year, as you can see. And then PayScale says that the senior data scientist salary ranges from 97,000 to 1,600,000. And I don't know if it is true or not, but let's see. Chris, do you agree with the salaries?
So the Glassdoor one, yeah, I think that's that seems to be in the ballpark, and PayScale seems to be right there as well. So yeah, I kind of agree with those two. I don't really agree with the Built in NYC. I don't know anybody in data earning less than 70,000, right? So I don't know who is earning 55. That seems to be very low. And I don't know of I know of one or two folks earning 250K, but these are really unicorns. You're not going to find that as being the normal thing. That is someone with a very large group of skills. That really, they do everything across that whole stack, and they do it really well. But like I said, that's a unicorn.
So it's probably from a very small set of skills to a very large set of skills.
Yeah, the one guy I know, he's certified in like 10 different databases. He knows 3 or 4 different programming languages. He's a rock star, right? And he can really demand very high amount of money because it's only him, and he'll get it done really fast. right? But I don't know, like I said, I only know of 2 people like him, and I know a lot of data folks.
I see. Let's see what is the audience think. So actually, you were almost correct. So we have, again, we have different data, job search websites, and everyone says that its ranges still from 11K to 20K per year. It's in Ukraine. And as you can see, it's probably better to go to New York to be a data scientist or to work in data than to work as data scientist in Kyiv. Or alternatively, Chris, is it better to be in New York as a data scientist?
I don't know that I agree with that. I ultimately, if I could earn, I think the cost of living in Ukraine is substantially lower than Manhattan. Where I think, I think of the apartments and I know what people pay for those. And yeah, in fact, we have had a number of engineers who came from Ukraine, went to the United States, did a project, actually asked to be reassigned back to Ukraine for a couple of different reasons, but ultimately the overall quality of life was, they got a lot more for their money in Ukraine than in the US. That said, everybody's different. Everywhere is different. In New York, those are the highest. If you go to somewhere like St. Louis or Chicago, those things are all gonna be down probably 30%.
I see. But I'll stay in Kyiv under the rain.
Yes. So now's the time for questions and answers. Does anybody, we wanted to leave enough time for everyone to feel free to ask some questions. And because now's the time, and so go for it. If anybody has any questions, feel free to either write them in or take your computer off speaker or mute and ask. And you can write it in whatever language you wish to write it. I'm sure we'll interpret it or translate it for you. So we got a question. How did I start career in data? So this is going to date me a little bit, so it gives you an idea. So in 1987, so a long time ago, in fact, the Cold War was still on. That's how old that is. I was actually at the university doing research on SQL, right, on this new query language called SQL. And we were doing some work on cell locking. And part of my interest was in actually currency arbitrage. Currency arbitrage, if you're not familiar with that, is the buying and selling of currencies, so that after you're finished the trail of currencies, you finish with more money than you started with. So imbalances happen in currencies. And so if I have dollars, I buy pounds, and then I buy euros, and then I buy yen, and I buy lira, then I go back to dollars. If you do it fast enough and you do it at the right time, you can actually end up with more money than you started with. And that's the whole goal of currency arbitrage. And every large bank does this today. And they will make trades, and they're very small differences, but they'll trade $1 billion 5 times within a second, and they'll end up with an extra $50 at the end of that transaction. If you think that's crazy, it's not worth it. Yeah, if you've got money sitting in the bank and you hit a button and 1 second later it's now $50 more, I'm going to sit there and just keep pressing that button. And that's what is currency arbitrage. So I actually started studying linear regression and hoping that would enable me to do some currency arbitrage. And it actually did function. It turns out it's much more complicated than that. But as a university student, I thought I was doing pretty good. But that was currency arbitrage. And that's where I learned, that my linear regression algorithms were good. And at the time they were better than most, actually. I worked with some stock brokerages to try and get them implemented. Turns out that, the speed was a huge factor. So I didn't have access to the environment properly. So ultimately I went away and did other stuff as well. But that was my first exposure to data at the university, and as a working and trying to get some work at a stock brokerage company in the Midwest. Any other questions?
Yes, we have. Can you give an example?
Oh, yeah, actually, we did a project. Well, so there's different ways of looking. So the question is examples of using data science in pharma. So there's actually, I have a number of projects that we've worked on. So one example is in pharmaceuticals, right? Where if you actually have what's called, you have a pharmacy, which is the business selling the drugs to individuals. And we use data science to make sure we have a customer. They work with the drug manufacturers, and we work to make sure patients are getting the drugs they need at the prices they need. So in the United States, I don't know, the healthcare system is a little different than other places. You actually have to pay some money for drugs depending on your insurance, right? Some insurances are very good and give you everything, some don't. And some drugs are very specialized and are very expensive. So what will happen is a patient will go to a drugstore. The drugstore will say the cost of this medicine is $1,000, which is at sometimes too expensive. So the patient will abandon or leave the prescription and go back to the doctor and say, hey, I don't have enough money for this. And the doctor will then work on something else. Well, the problem with that is there is time being lost while the patient is, going back and forth to the doctor. So what the pharmacies do is the pharmaceuticals, the manufacturers of the drugs, they go in and they tell the pharmacy, if this is happening, let us know, and in real time, we will offer them a better price so that based on what we believe they can actually afford. So they make generic prices, but this person might be poor and they can't afford it. So we wrote algorithms that would actually look at the person, how what the drug cost was, what the manufacturing cost was, what is the, how much money the person makes, and all these other variables. And we actually would offer them a price. Here's what the price should be. So instead of giving them $1,000, right, or saying it's $1,000, we'll say, well, the drug still costs $1,000, but here's a discount from that of 75%. So it's now no longer $1,000, it's $250. And the goal here is to get it to a point where that person can actually afford it and it becomes reasonable for them. So it's actually a very interesting project in helping people get access to medicine. Another project we're working on is actually in it's called laboratory work, right? So in the laboratory, everybody's gone and given blood or had a piece of flesh taken off them for whatever reason and sent to the laboratory. Well, these are called laboratory management systems. And what we're trying to do, and this is an active project actually right now, I'll be meeting with the folks in a couple of days, is really to help them understand how do you make sure everything is going through the system properly and gets tracked properly and is assigned to the right thing. Because today, a lot of it is verbally communicated. The doctor literally is examining through a microscope, measuring, the tissue sample is X, 1 centimeter by 3 centimeters. It is half a centimeter thick. And they're doing this verbally into a microphone. Well, we're using natural language processing to take that and convert it to a data, right? That data then is then entered into systems, and we're looking for, patterns, and we're basically collecting data and helping them optimize the path of that of that environment through there. I have other examples, but in the pharmaceuticals and pharma, there's just tons of research and data science being used there today. Did that answer your question?
Yes.
Excellent, thank you. Any other questions? A great question, by the way. Where do companies get their data? Oh, so that's another very good question. So at Cablevision, as Chief Data Officer there, Cablevision is a company. It was a $20 billion company in cable and communications, and they Vita. What's a company that would what's an equivalent to a cable company, Cablevision in Ukraine?
In Ukraine, I would say Ukrtelecom and Vola.
Okay, so Cablevision provides TV, phone services, all of these different things, and there's two different areas, that we're as examples we can use, very simple areas. So one is with what I call the infrastructure, right? So the infrastructure that's used to provide internet services or television services or phone or et cetera are all, you physically, there are devices that are in the data center on the road that wires from pole to pole, and then they go into boxes near your house or even in your house. Each of these pieces of equipment actually collect data on everything going on today. I would call it logging data. So I've sent you a packet of data, you've received the packet of data, the packet of data was received correctly. And this gets logged by all of the equipment across the entire path. And so it's used to see if, diagnostically to see if the infrastructure is oversaturated, if it's getting enough power, if, maybe we need to add additional infrastructure if we're, if we're consuming it too much. Could be that, there's other problems where, the wind is blowing a wire and making it connect, unconnect, connect, un. So it's basically using that, and so we collect all this logging data and we run analytics across it to try and predict outages, capacity, etc. A more interesting area that we would collect data from and potentially more frightening, is that we would collect from every time, in every household that was using our services, you would have a set-top box. The set-top box is the device that you use the remote control to change the channel, for you. What we would do is every time you hit that channel change or channel tuning button, either channel up, channel down, or jumping to another channel by typing in the channel, we would collect a piece of data from the set-top box. We would look specifically, what channel you tune to, what time is it. We also asked, what's the temperature of the set-top box? What's the signal to noise ratio on the cable signal coming in? What's the voltage of the inbound electricity as well? So we could see what was being done from a very low level and actually very small packet of data. But we had, every time you hit the channel tuning, and to think about it, we only had 3 million customers, which meant we had something like 8 million devices out there that was collecting data. You have other companies we're working for currently, Charter, for example, who have 28 million subscribers, with over 60 million devices out there. And if each of those devices are sending data, and at Cablevision, we're sending data, you literally collect terabytes, petabytes of data every day, and you process the data. And the way that we used it actually was, we would try to predict who was watching TV at any particular time. A good example of that is if you're Toyota and you sell minivans, right? Your target is women with children with a large enough disposable income so that they can afford to buy a car, or they need a car. And so this is your targeted person. And so what TV are they watching? We would know exactly what shows they were watching and when they were watching them. We knew at 3 o'clock they were not watching. They were going to pick their children up from school. We knew that because there's lots of things that are going on. So we would know what to do it, and we'd go to Toyota and say, here's when you want to advertise. Here's the neighborhood you want to advertise in. Here's the time that you want to advertise, and give them basically the information for that advertising. In fact, it's so valuable that business, we created a new business within the company, and within 4 years, it was doing $200 million of new business. It's crazy to think about it, how it could be making so much money, but Coca-Cola wanted to advertise, American Express wanted to advertise, all of the drug companies wanted to advertise, because now you knew specifically the individuals. And actually, it's even more detailed now. If you're watching TV on your device, right, which everyone does, instead of in your home, the cable companies look at the home, your device manufacturers know it's you, right? So it's even getting creepier as you go along. And in fact, we're working on a project right now to collect data from devices, handheld devices. So we know every time you touch the device, we know every time you type a letter, what you've typed, who you've typed it to, all of that stuff. So
what about data protection? Do you have?
Of course, we comply with all of the rules of data protection. But remember, in these companies, when you select terms of service, right, you're accepting that we can collect your data. And if your cell phone is that way, and your Netflix ID is that way, and your cable company, all of those, when you accept your terms of service, if you go through it, it says we are allowed to collect data about you for multiple purposes, right? So,
Unbelievable.
and many of them will say, if you don't accept it, then don't use it, right?
Yeah, don't use.
In the beginning, it wasn't that way. Anyway, so I hope that answers your question. It's fascinating where data is going. In fact, it was funny. We actually, based on TV viewing behavior, we could predict whether or not a couple was going to get a divorce.
Oh my God. That's
So,
too personal.
So I actually, as a chief data officer, I actually changed the rules and said, I forbid a piece of data that was critical to understanding that was being collected. We deleted that feature for data science lingo, that feature from our data set so that we couldn't compare it. We also removed race, right? Was one of the other things. We removed race from that. So we could honestly say no decisions we made were based on race.
Awesome.
Right? So it's interesting. Another actually, well, I got lots of those things we could talk about. So is it getting harder to collect online data due to cookie consent and other data protection laws? Yes and no, right? Like I said, is even all the cookies that you're looking at today, they give you an accept or don't accept, right? And in fact, if you don't accept, they basically don't let you access most of their site. So by and large, most people hit accept simply to get access. So do I think it's getting harder? I don't think it's getting harder, but I do believe that boundaries are being more clearly defined so that there are rules and it's being explained. What I mean by that is, in the past, companies would collect your data without your knowledge that you were collecting your data. And now they're saying, we are collecting your data, and you're aware that they're collecting your data. Behavior hasn't changed, but at least now you know they're collecting your data, and you can do something if you wish to. You can take some action. Some action is, some people have called the companies to say, hey, you know, they want access to the service, but they don't want you to collect the data. And that has caused companies to change some things. So I do believe it is changing for the better. I don't believe that, you know, data isn't being collected though. I think it's just, you know, now you know they are. Does that answer your law or your question? Yep, cool. So an interesting thing as well, the laws in the US are very different than the laws in Europe. And so it's interesting how companies are actually moving their database, their data servers to different locations and using that as a reason for being exempt from laws. So the laws for data collection in the United States are less restrictive than those in the EU, which is the GDPR. So a lot of the companies have moved their servers to the United States. Some countries have said you can't do that. Again, you know, it's questionable even in those countries whether you can prevent companies from moving stuff or not, right? So but it is more complicated, but it's better. Any other questions? So I thought I'd end with one last project. I'd talk a little bit about one last project that we were working on, and it's the reason I talk about it is because it's actually, you know, how, you know, data scientists can actually, and data workers can actually make a good difference in the world. So there is a project that we are looking at and we've worked partially on, where if nobody knows, there's a company or a group in the United States called the Audubon Society. The Audubon Society is a group that protects birds in the wild, right? So it is nothing more than an organization that have decided they want to help protect birds that are in the wild and are in, you know, they need protection from human activity. So one of the project is actually, if you look at the data sources that are being collected today are from, you know, scientists and researchers that literally are in the field. You've seen them. They put radio trackers around the neck or the foot of birds, and they physically follow them around, you know, their migratory pattern from Alaska. In fact, we were talking to a researcher who was out in the field using a satellite phone in Alaska. And they were in a, you know, following these birds south from Alaska all the way down to the Baja California, which is on the south of San Diego and in Mexico. And they would follow them through this whole migratory pattern and watch the activities of these birds. and you were collecting data from them. The other people, there are what are called bird watchers. So I don't know if in Ukraine there's a lot of bird watching, but literally people as a hobby, they go out and they bring their binoculars and they observe birds. And the enthusiasts, they literally write, I spotted a woodpecker at this time at this location, and they actually enter that into a website. And actually they provide this data. Some people actually provide it at a cost, some people provide it for free. Then there's hunters, right? The hunting organization. So let's say some researchers in Alaska put a band around the foot, or someone in Canada, a foot of a goose, and that goose is flying south for the winter, or this is when hunters come out and shoot the birds. And in the United States and Canada, if there's a tag on that bird, you're required by law to give that information either to a park ranger or to phone. There's normally a phone number you say, hey, I caught a bird, here's where I caught it, here's what it was, and information about the bird. And they record that, and they know now that that bird went from, you know, Canada to, let's say, Illinois or Missouri and was shot. So they know the pattern in the birds and the numbers and everything. Anyway, so what we're doing, the project is ultimately to do two things. First is to simply predict what is the migratory pattern of all of the birds in North America, every single bird species, build an encyclopedia so that every bird and its flight patterns are known. Some birds migrate, some don't. And so the second part of that is to understand, you know, what properties would be interesting, since as a piece of information, the Audubon Society receives hundreds of millions of dollars in donations every year. So they want to know what property or what land they should buy to help birds make that migratory pattern or that trip back and forth more easy, right? So they can be healthier. So they buy land, they protected the birds that are there, and so birds now can land on this property and go out. So what we're doing is we're helping them using Zillow and things like that. We find land and property that becomes available for sale. We review it as far as, you know, how many birds could potentially use it, how endangered are these birds? Are they common birds? Are they, you know, endangered birds? And we rate the, you know, the value of that land as a protection area, and then we give ratings to the business to make recommendations. So it's actually a fascinating thing, and ultimately it is what's nice about it is that all of this work is there to help protect animals in the wild. And there are other projects like that going on, and so data science can actually do a lot to help improve the environment as well. So there's lots of interesting projects out there. Anyway, an interesting story. That said, any last questions from anybody? Well, it certainly has been a pleasure. I appreciate everybody attending. If you have any questions, feel free to reach out. And then Vida, if you have any other last comments?
Yes, so we are coming to an end, and we will appreciate if you finish the last poll for today. And while you are finishing, the next slide. And the next slide. Yes, so if you have any questions, you are more than welcome to write an email to any of the addresses, either to Team Dressler Consulting or to Team DEVrepublik, and we will be more than happy to reply to all your needs. So feel free to contact us, and we will be happy.
Well, thank you, everybody. I wish you a great day and a great week.
Thank you very much.
Bye-bye.